In this video, we are going to start working on solving equations that have trig functions inside of them. So to start off, I want to solve this first example first to kind of help with that first paragraph to make you understand why we're doing that there. So let's start here. We want to solve the equation cosine of something, some theta, is equal to 1/2. Now, I put the unit circle here just to kind of make it a bit easier. But what I would do is I would go through the process of, okay, cosine is 1/2. That is the small side. So I want the x to be short. Okay, well, that would be my tall triangle right here, right? That is where my cosine is 1/2. So one answer could be pi over 3. There's an answer. All right, but I could rotate all the way around, so add 2 pi to pi over 3. Well, 2 pi is just 6 pi over 3. That's a 2. So if I add, then I get another answer, 7 pi over 3. And then I could just keep adding those sixes, get 13 pi over 3. But I could do this forever. So we need a better way to write that. So one way we could write it is we could say, hey, pi over 3 plus, and then we're going to put 2 pi because that's all the way around. That's what we were adding, right? This is 2 pi. And then we're going to put times k. What the k is going to be, the k is an integer. So we'll write integer. Remember, integers are just non-fraction numbers, positive and negative. All right, so you pick your favorite integer, 1, 2, 3, 4, 5, 0, negative 1, 2, 3, negative 5, negative 14. You plug it in there. If I do k is 1, then I'd have 2 pi times 1, and that's just one revolution, right? That would be my 7 pi over 3. If I did k to be 2, my answer would be 13 pi over 3. But I could also go the other way and do a negative 1, right? And make it rotate the other way and get into negative angles. All right, but there's another answer, so I'm going to highlight that one. Now, another answer would be, okay, we are looking for when cosine is a positive 1/2. Remember, that's my x. When is my x a positive 1/2, the short side? And that happens right here. So the other angle is going to be the tall angle in quadrant 4, which is 5 pi over 3. And I could keep adding 2 pi around like we did above, but I'm just going to go ahead and jump to that. So my answers are the pi over 3 plus full revolutions forward and backwards, or clockwise and counterclockwise, and then also the 5 pi over 3 forward and backwards. If you notice, if you were to go through this circle, this is the only time that first one, the x coordinate cosine, is 1/2. So for any cosine equation, we're going to have two answers in our first revolution. Any sine answer, we're going to have two in our sine because every number has two. And then our tangents will be that same way as well. Okay, so let's look at our sine now here. Now, what's going on here? It says if we want to find all possible solutions, then we must add 2 pi k, where k is an integer. What we're doing is adding full revolutions, 2 pi. All right, so let's do another one here. Sine of t is 1/2. So we're looking for when is sine, which is y, 1/2. So I'm going through and I'm looking for my y to be 1/2. I know there's only two in one revolution. So I know t is equal to, okay, well, y is 1/2 there at pi over 6. And then I know I'm going to add a full revolution times k. My second answer is going to be the 5 pi over 6, the other one I highlighted over there. Those are where my sine, the y, is 1/2, and I add 2 pi k, and k is an integer. So there are my two answers. So it's not bad when it's given this form, and if you know your unit circle. Now, it's really great when you have one. Some calculus courses will give them to you, some will not, depends on who you take. So, but if not, we could use that same, okay, I know sine is 1/2. That is, I want my y to be short and I want it to be positive. So it would be my short triangle because that's where y is the small side. But I also want this triangle over here because y is also the small side and going up. So it's still positive. And we could say, okay, that's the small triangle. That's pi over 6, which means that this one is 5 pi over 6. Both sixes. All right, so it's not bad if you have a unit circle. If you don't, you could still do it the way I've taught you guys this semester. Just going to take some time jumping from here to here. That's going to be the tough part. All right, now what if there's more going on in the equation? So there's a how-to. I don't like to go over those in videos because people tend to just glaze over in class, so I assume the same for the video. All right, so what I'm going to do is I'm going to write down the problem first. Now, this gave me a window to find my answer. This said they want all answers to be between 0 and 2 pi, so we're only looking for one revolution. Just like solving something else, like if we were going to solve for like a absolute value or square root or anything like that, our first goal always is to get that thing by itself. So I'm going to show the steps here just so we're good. I got 3 there, add to both sides, so I still got 2 cosine theta equals a -2. Now I'm going to solve for the cosine theta by dividing by 2, which means we're looking for when is cosine theta -1. So we're looking for, okay, if cosine is a 1, -1, or 0, then I know I'm looking for the answers on the axes. All right, so right here at 0, this is a 1, 0. Pi over 2, if I rotate that far, it's a 0, 1. Over here is a -1, 0. And down here is a 0, -1. Those are the only time my cosines and negative and sines will be 1, -1, or 0. So that means that my theta then is going to be at, okay, well, it's this revolution here, which is a pi. And I won't have any more. That's the only time it's 1. And I don't have to do the plus 2 pi k here because of the window. They said, hey, only one revolution. So there is my answer. Theta is pi. That's the only thing that will work. All right, we have another one here, a couple more in this video. These don't change a whole lot. It's just getting down to this part and understanding what to find there. All right, so I'm going to write this down. 2 sine x plus 1 equals 0. That 1's outside of the x. They would told us with parentheses otherwise. And this is just for one revolution. All right, so I'm going to, first things first, -1. So I get 2 sine x. You can make this jump if you're able. Just straight down to sine x equals -1/2. All right, so I'm looking for sine to be negative, right? So if I'm thinking about my first revolution, sine is y. So if it's negative, it's going to be in quadrants 3 and 4. All right, sine is y, and it's saying it's a half. So the y has to be the small one because I know the half is the small side. So I know it's that angle and this angle. So this one is going to be, that's a 6. I know this is 6 pi over 6. So this one is a 7 pi over 6. So that's one answer. 7 pi over 6, comma. And then I know that this other answer, I know this is 12 pi over 6 because 12 over 6 is 2. So one back is 11 pi over 6. So that's another way we could do it if you don't have the unit circle in front of me. So that's an 11. Looks kind of strange. 11 pi over 6. So those are 2 answers. Like I said, things involving sines and cosines, if it's one revolution, for every revolution, one revolution, you're going to have 2 answers. Now, I have to mention this because some of you guys are going to be like, oh, that didn't happen here. That was one answer. Now, that's when the angles or the answers aren't on the axes. So if you notice that if you go through there, cosine is 1 only at one spot. Cosine is -1 only at one spot, and 1 and -1 for sine as well. So those will only have one answer like we had here. But if it's not that, any other thing that's not 1, -1, or 0, you will end up with 2 answers. All right, that's because of the revolution. All right, couple more here. They're just going to get just slightly more complicated. So this is cosecant theta equals -2. And then let's make note of our answers. We want our answers to be between 0 and 4 pi, so 2 full revolutions. I don't think in cosecant, so when I have a plain equation like this is what I'm going to do. I'm just going to go ahead and flip them. So this is 1 over sine theta, and then this is a -2 over 1. So I just wrote the definition. You could think about it that way, or we could just flip. So sine theta is equal to -1/2. So I flipped them, and then I just flipped the equations. If you can think about it and flip it right there, perfect. So we're looking for when is sine 1/2. We just negative 1/2. We just did that. So theta was 7 pi over 6. And this is how we get our next one. I'm going to go ahead and write 11 pi over 6 too. And we want them again, but 2 revolutions. So I want the next 2 answers. So I'm going to add 12 pi over 6 to both of them because that's 2 pi. That's 1 full revolution. So that is 19 pi over 6. And then I'm going to I'll add it to 19. I add it to 11. It's going to be 23 pi over 6. So notice we were dealing with a sine. So our answer, sorry, I think I blocked something out there. Let me just leave it alone then. That's our answer, those 4. We're dealing with a sine, and every revolution with sine, we gain 2 answers. So that's why we have 4. Okay, tangent of theta minus pi over 2. I'm going to go ahead and tangent, there's a couple identities here. Tangent of theta minus pi over 2 is actually the same thing as cotangent of theta. This was one little thing. I've never really used it outside of when it's set up nice and pretty like this. This is one of those things when I see that, I'm like, I know it's something. I got to look it up. All right, so this is equal to cotangent then. So cotangent theta is equal to 1. Let's go ahead and note that we're only doing 1 revolution. So I'm looking for when is cotangent 1, or you could flip them over. Cotangent flipped over is tangent, 1 flipped over is 1. We want to know when is tangent 1. So tangent is 1 when sine and cosine are the same. So that happens at pi over 4. That's my middle triangle. All right. It doesn't happen at 3 pi over 4 because that'll be, let's draw the quadrants because I think it may be a little difficult to picture. This is pi over 4. Okay, that has the same X and Y. I said it backwards, but you get the point. This one over here is another fourth. It's going to have the same numbers, but notice that going up is positive, but to the left is negative, so it doesn't work. Now we have a fourth triangle down here. By fourth, I mean pi over 4. The X is negative and the Y is negative, so if I do a negative divided by negative, I'm going to get a positive. So that's actually the next answer. And that's going to be pi over 4. This is 4 over 4. So one more is 5 pi over 4. And then our last one down here, bit off there, but you can kind of tell really quick. This is going to be positive and a negative. That's not going to give me a positive 1. That's going to give me a negative 1. So those are my answers in 1 revolution. All right, we'll just box these on this one because I think my highlighter's messed up. All right, so those are those 2. It gets a little more complicated, mainly if you can't do know that. But again, I want you to see the theta minus pi over 2 and be like, oh, that is one of those identities that we looked at. All right, 2 more for this video. We have a tangent of x equals a rad 3. Now, this one is a bit tough to kind of work through, so I'm going to give you my memorization techniques for these. So tangent of, and I've given them to you before in a video, but I'm going to make sure, I think I have, I hope I have. If not, I need to add it in somewhere. Tangent of pi over 6 is going to be, depending on where it is, and we could put a plus or minus here, plus or minus pi over 6. Ooh, let's do this actually. If it is, sorry about that, n times pi over 6, and it doesn't reduce, does not reduce, does not reduce. So you can only use numbers that won't reduce. Like what I mean is you can't use 2 because 2 pi over 6 is just pi over 3. You can't do that, right? For this trick to work or memorization technique. So when it's like that, it's going to be a plus or minus depending on which quadrant it is, rad 3 over 3. Tangent of n times pi over 4, same rules. You can't use 2 here. That'd be, or 4 or any multiple of 2. This is going to be plus or minus 1, hence what we had in that last problem. And then the last one, tangent of n times pi over 3. Okay, equals plus or minus, and this is going to be square root of 3. So how I have these memorized is I know those 3. I know it's a bunch of 3s. The 4s I have memorized to be a 1, and the reason I have that memorized, it's nice and easy for me, and it helps with sines and cosines, is I know that when it's a something pi over 4 that sine and cosine are the same, which means when I divide them, it's going to be a 1 or a negative 1, depending on their positive negative. Okay, how I keep the rest straight. This being a 6, I know it that it's either, real quick, I know it's either this one or that one. I have that memorized. Rad 3 or rad 3 over 3. This one has a 6, and notice these have two threes, which makes 6. This one has a 3, and it has one 3. So that's how I've kept it straight. And then all of the sign, like 0 and pi over 2 and all that stuff, I'm literally just writing the point down and doing sine over cosine. So like this is 1 over 0. So I know tan of that one, sine over cosine is going to be 0 over 1. So I know tangent is 0. Here it's 0 or 0, 1. That's going to be 1 over 0, so D and E for tan. Here is negative 1 over 0, so sine 0 over negative 1, so the answer is 0. This one, 0, negative 1. That's going to be negative 1 over 0. That's D and E. So that's how I get my tangents from there, depending. Okay, I know everything over 2 is here and here, and then any multiple of pi is going to be there. 1 pi, 3 pi, 5 pi, and so forth. 2 pi, any number pi. All right, so that's how I have that memorized. It's helped me out to be a little quicker. So looking at this, okay, so how I do this is I see that pi over 3, so I know my answer, and it says find all solutions. So we're going to use that thing that we did at the beginning. My answer is going to be pi over 3. All right, so I'm going to go ahead and write down on a graph because I'm going to use this here in a moment to make a point. All right, so this is pi over 3, which is my total side right here. All right. I know that's going to be rad 3. I also know, I'm going to put pi over 3 here. This also gives me that same ratio, except for it is negative. So we don't want that one. Because it's if we think about it, if I go back, this is positive divided by negative. It's going to be a negative, not a positive. Okay, if I go down here and I do that, right? This one's the same ratio. I know that all the threes are going to spit out that rad 3, but this one is a negative divided by a negative, which is a positive. So this was a 3 over 3 here. One more is a 4 pi over 3. So 4 pi over 3 is another one. Okay, this one down here, right? If it'll ever straighten up. This is negative and a positive, so that's going to, if I divide those, I'm going to get a negative. So that one's not an answer. So those are my two answers in one revolution. Now I could do this. Let's go ahead and do it like we did earlier. That's okay, pi over 3. And then we're going to have a 2 pi times k for that revolution. And then we're also, would we say 4 pi over 3 plus 2 pi k. So that answer is great. Like we have two answers. Now, we actually, in math, we always want to keep things as simple as possible, especially with our day and age. Things are going into computers. Every computation in a computer has a literal cost, like money, because you got to buy storage to do everything. Now, here's the difference with this tangent and cotangents. All the other ones, like when we were doing sine and cosine, like if I do cosine or sine, I mean, the answers are the same here and here, right? This one and that one. They're the same. So I would have to do like 2 pi for that one, and I would have to do 2 pi for that one. Like I can't do them together. But if I look here, I could do 2 pi and then 2 pi again, but these are the same like angle right there. That's how the trig works, right? This is the same as that. So they line up perfectly. So instead of adding a 2 pi, we could just take a pi and add it in. Do you see if I add pi, I get there? And then if I add pi again, I get there. And then I just keep going, and I'm going to hit every one of them. So instead of having two answers, we could do pi over 3. And instead of doing 2 pi, I could just do pi k. And that'd be a great answer. That covers all of those, but in one statement, instead of doing multiple and having to do more steps. All right, I wrote all over that side, so I'm going to have to delete it. I hope that works for you. Say one more for this video. I don't want to make them too long. Oops. All right, I got to do this kind of weird, so don't judge me that it's all kind of jacked up. I had to like color over it because there was stuff I covered up earlier with this, and I should have sent out as a PDF. You don't care anyway. Okay, here we go. So this next problem. Okay, we have 2 times tan x plus 3. The plus 3 is outside of the tan, equals 5 plus tan x. And then notice that we are looking for 1 revolution. Okay, equations work the same. The tan x is like playing our variable this time. So I get 2 tan x plus 6 equals 5 plus tan x. I'm going to minus tan x from both sides. So I get tan x plus 6 equals 5. And then minus 6 from both sides, I get tan to be -1. Now remember that we know that our tangent is -1. At our 4's, we just have to determine which 4. So something pi over 4, something over that though. Okay, I know that pi over 4 here is going to have a positive x and a positive y. And if I divide that x and y, I'm going to get a positive 1. So that's not it. But I do know that it's the 4th here, because this is a negative and this is a positive y. So when I divide those, I'm going to get that. Okay, this is 4 pi over 4. So if I go back 1, I'm going to get 3 pi over 4. So there's one answer. This answer down here, which is a 4, I'm going to have a negative and a negative. If I divide a negative and a negative, I'm going to get a positive. And then our last answer is down here. And it is a positive and a negative. So if I divide those, I also get -1. So that was, okay, this is 8 pi over 4. That's all 2. If I go back 1, it's going to be a 7 pi over 4. So the second answer is 7 pi over 4. So that's this answer. With no interval, what I would have done, okay, general, or how about this? All solutions, different problem. All solutions, it would be x is 3 pi over 4 plus pi k, where k is an integer. That would be all my solutions. I use pi for tangent and cotangent.